Hello and welcome to this fourth video in our series on just playing around with Snake in 3D and aiming towards, I don't know, creating a community of snakes and things. Okay, so in this video I wanted to have more fun. The last few videos were just setting up the basics and dealing with a few bugs. So I've made some changes, some rather large changes between last video, video 3, and this video. So the first thing you'll notice, I've got two snakes. They look pretty similar, except I've got one, the original one is the one far away, racing around, and our new one is here. So I'm going to talk about him in a moment. But the first thing, talking of playing around, I've also got like moon gravity on as well, which makes jumping around a bit more fun. What I want to do is basically, instead of having spheres fly out here, let's just make each one of those spheres a snake. And so then we'll get loads of snakes generated and flying around. So let's do that. Let's do that straight away. So we've got our community of snakes. Right, in the environment, by the way, I've added that snake 3. I'll talk about him a bit later. Basically, I'll talk about him a bit later. Let me stop talking. Right, so let's make a prefab. I've got a prefab here already made of snake 2. How do you make a prefab? Basically, once you've got an object in your world like this, I've got snake version 3, snake mach 3, which I'll talk about later on. You drag that into your assets folder, and that generates a prefab. And this prefab means like a pre-made object that you can now drag into different variables, game object variables. For example, in my scene, I've got this egg thing which pokes up out the ground, which is my fountain. And what I've got in there are two spaces for what gets spawned. Let's show you that in the code. So I've got a little spawn script, and at the top there we've got a public WTS, which means what to spawn. Okay, I've actually got 2 spaces. I've also got like a brute mode for that. I won't explain that here. So this variable corresponds to this space here on the inspector. So what we can do, go back into our snake folder. I can now select the egg and then drag that prefab up into that space. So instead of an example ball, those little spheres getting spawned, we'll now spawn loads of snakes. I think. Let's see if it works. It should be as easy as that. Simply changing over the prefab. Right. So there are our 2 snakes. Mach 2, who's a worm. He's burrowed down into the ground. Mach 3 snake is much more slowly walking around there. Snaking around there. Okay, here's our fountainhead. Right, without much further ado, generate some snakes. Okay. How many snakes did it generate? It generated 919. No, either 99 or 999. They're all kind of vying for space. Okay. Let's do something. Let's make... That's not as amazing as I expected it to be. Let's instead make the move a lot faster and make sure we're not generating too many. Oh, there was almost 1,000 snakes generated. So we want... let's just have 99. Let's not go crazy. And then we want our snake 3 prefab to go a lot faster. So speed... Let's make him 10 times as fast. Okay, off we go. I'll go straight to the fountain this time. There he is. Right. And switch on. There we go. Oh, I know what they're doing. Okay. Let's talk about the behaviour of snake 3. No, let's not. Let's. I need snake 2. I need snake 2 to be in there. I just want to make sure. Let's just drag snake 2 in there. basically all of those snake 3s are going to have the same path for a particular reason. If you know about Perlin Noise, you'll probably be able to guess what's going on. Okay, so it's snake 2, snake mach 2, to be generated in our fountain. Let's see what happens this time. Okay, much better. There we go. That's what we expected. Okay, so our original version of the snake moves around in a random direction. Oh, this is pretty cool. This is what I kind of imagined when at the start of this project, having lots of snakes around. That's fantastic. I also think we need to play around with the scale of each snake so that, for instance, over here we could make like a little aquarium. It could be invisible or we could see it. And then inside these tiny little cute snakes could be, hundreds of them, a bit like this, going around in a more like contained place. It's kind of cool having them out in the wild like this. Right. Right, let's explain about Mach 3. What changes have I made? Okay, the first thing, and to explain why they all kind of moved off at the same rate, was that the new snake, which I've called the experimental snake brain, basically I just copied all the code from the last video. So snake brain for Mach 2 snake is exactly the same as at the end of video 3, the end of the last video. So I think this is all the same. And so because I was experimenting between filming, I thought I'll make a new script so I can keep a track of things. And then if I, again, experiment or we make snake Mach 4, then I'll make a new script again. Okay, so the reason why they were all those generated spawn snakes were moving the same way is because if I go down to, where am I going, check direction, instead of choosing the new direction, which we store in the variable which_d, by a random range, I'm using Perlin Noise to decide the direction of the snake. So that means every time we run the code, we'll get a new, we'll get the same path, the snake taking the same path. So if we get a really interesting path and we want to save it, we could always return to it, whereas the random snake paths, they're just random and they're gone. Next time you run the code, it's going to be something different. Okay, right. So how does this work? So we've got the same kind of dice idea, i.e., if our old direction plus the new direction adds up to 7s, it's like the opposite sides of a dice, then we go and grab a new direction again from this Perlin Noise function. But what I have to do then is make sure that the number we're putting into the Perlin Noise function, i.e. the total steps that the snake has taken, is incremented by 1. With the random path, all you have to do is go and grab a new random number, just make sure it's not a direction that adds up to 7 plus the old direction, meaning it's going back for its body, and you just keep doing that until you get a satisfying direction. It doesn't move back through the snake. With the Perlin Noise, I'm only after one-dimensional Perlin Noise. The Perlin Noise in Unity, in the math function, takes 2 parameters, and I'm just leaving one of them at 0. And the first parameter, all I'm putting in is the total number of steps that the snake has taken. So total steps, I've just made an integer variable, and that increments every time you move the snake. So if the Perlin Noise forces the snake to move back through its own body, as we calculate using this little dice algorithm which I came up with last time, then we just increment the total steps and hope that we get an okay direction for the snake. If we don't, the while loop will just keep going around until we find a satisfying path for the snake, or an okay path for the snake. Okay, so that's how that works. The other big change, this is the biggest change, and perhaps the most important change, concerning our new snake, the Mach 3, is that we can now grow the snake and we can shrink the snake. And I've just mapped those to, where's my update function? It's up here. I've just mapped those very easily to mouse presses. So if we press the left mouse or mouse button 0, then we run the grow snake function, so we add a segment. If we click right, then we'll get we call the shrink snake function. As easy as that. Now, if you've ever tried to deal with arrays in C# or on Unity, you'll come into some problems if you want those arrays to be kind of dynamic, to get bigger and smaller. So basically, you can't use arrays to do that kind of thing without copying them and using a temporary array and swapping over and complicated nonsense. So C# provides you with a list. So what I've done, I'll show you how we grow the snake and shrink it in a moment, but what I've basically done is change, if we look at the snake brain, instead of having an array of segments, it's fairly simple. We have a list of segments. So I've kept that name the same, and I didn't have to change much code. It's really quite impressive. So if we go down to, for instance, let's have a look at growing our tail or generating the tail. I've called in the Mach 3 grow tail instead of generate tail. And in this one, I don't translate the tail out at the start. I just leave I think it looks better when the snake first moves off. I leave the tail now all bunched up in a like a little group, and it just moves off like that, so it looks like it's uncoiling. What was I talking about? I was talking about dealing with the list of segments instead of array. So if we go to a familiar function, check direction. For instance, when we're rotating our snake segments, I can just refer to segments, the index of the segment, just as though we were dealing with the array. So I haven't had to change any of that code. It's literally just the declaration up here. That's it. Okay. I did change a few other things to do with. I hate it when this little record thing goes on here. How do I get it off? Right. What I have changed is in move snake. I don't know if this was like a bug waiting to happen, but what I used to do was change the which segment to the previous segment in the list, and now I'm going to the next segment in our array, in our list. So I've changed that. Right, let's just have a look at grow segment, shrink segment, in case you're wondering how to do this. This caused me quite a few problems, so I'll just show you. Okay, grow snake's a lot easier. So all we're doing is adding a segment to the end of the snake. So first, we make a new temporary game object, store it in S, and this is exactly the same as in generate the tail or grow the tail, which starts at which is how the snake starts at the start of the program. Then we make sure that this new segment copies the which segment or the end segment in the tail in terms of its position, and the rotation is very important. It's got to face the way that all the rest of the snake is facing. And then we use this, I've just remembered something else that we did have to change in the code, sorry. Then we use this function insert. And so that's like an array function, in this case a list function, which allows you to insert this new object, so our new segment S, into whatever index in that array you like. So we want to put it on the end of the snake, which is index which segment. I think that makes sense. What I just remembered was that instead of saying segments.length -1 to find the end of the tail, you would write segments.count. So list uses dot count instead of dot length. So you might see dot count. So that's the other, I think that's the only change I had to make. Right, concerning the lists and arrays. Right, how do we shrink the snake? How do we shrink the snake? So we want to remove a segment if possible. And what I said straight away was, if the segments count equals 3, so if we've got exactly 3 segments in our snake, then just return. So we can't do that. So the snake will only be like 3 long. I haven't tried yet. Let's make it 1 and see if that actually works. I haven't bug tested that. I haven't debugged that. Right. So we can't, like, because, well, as you'll see in a moment, there could be some problems, because if you remember, in the beginning video, I wanted to keep the script that controls the snake, so the snake's brain, actually part of the snake's body. So it's kind of a recursive structure in our snake, meaning if you destroy that part of its body, then, I don't know, this script no longer exists and it will just disappear. I don't know if that will cause any problems or not. So basically, we never want to destroy a segment that has this script attached to it. Okay, so yes, that's explained here. Only remove a segment if not the brain segment. So I've written, if segments, which segment, so the last segment, if that game object, get component experimental SB, SB standing for snake brain, and experimental SB is the mach 3 script for our snake. If that equals null, so basically, if this segment hasn't got the brain on, then go ahead. Otherwise, we can't remove a segment. It just misses this out. Okay. Then we use this function. We go to the segments array or the segments list, and we use the function remove at. And all that does is remove the item in that list at this index. So which segment, so that basically the tail end of the snake is gone. However, I noticed, I didn't realize this, when I did that, the snake would leave like little poops. The actual object, the segment, would be removed from the list, but not from the world, not from the Unity scene. So in fact, if I delete these two lines out, and we go and run it now, the snake will leave those segments behind, which I kind of like. It's kind of a nice little behaviour. We could use that to have the snake lay eggs, for example. Right, so if I press left mouse key, we're growing the snake, and it's gone. If I press the right mouse button, then it's leaving these segments which we're deleting. Can I get it down? Yes, I've got it down. You can see it just in the distance there. It's 1 segment long. Let's just pause the game. I didn't get any error messages, so I think the array list is staying within range, so that's okay. So let's just have a look at snake 3. There he is. Just 1 segment. And I've made the list, the array, public as in the previous snake. And yes, we've got 1 element at index 0, so which segment equals 0, head segment equals 0, and that's got the snake brain on through those protections we looked at in the shrink snake function. Okay, so that's all working fine. But we did leave behind some cubes, not these, I think they belong to snake 2. Yeah, here's snake 2. Ah, there's a poops down there. Right, can I select one? Yes. Okay, here's a snake poop. So it was removed from the list, but not from the scene. So all I did was it just took 2 lines of code to sort that out. So before we remove that segment from the segments list, we need to grab hold of it. So I just made a temporary game object variable called poop, and that equals the segment we're about to remove. So segments the index we need, which segment, and .game object. We want the actual game object. And then after we've removed it from the array, now we're safe to destroy that object, which is stored in poop. There we go. And so that destroys it from the world. Okay, so we can have a cute little snake. So let's go back to the scene. Snake 3. I also made all of its kind of like variables public, so we can play around with it. We can make it go a lot slower again, so we can kind of look at its behavior. Spread we can change here, so that's how far apart each segment was. Segment number to begin with, we can make it really long straight away. Whether it's ready or not, so that's whether it starts generating, it generates its tail from startup or not. And we made sure that was false if we generate like a new snake from itself, for complicated reasons. Step change, that means that's a new variable on the Mach 3 snake. So that means instead of changing direction every 10 steps, we change every 3 steps. We could then, now because we've got that as a variable, not just hard-coded as a number, we could change this every time the snake changes direction if we wanted to. But because it's changing every 3, it means we've got a lot more variation. Right, and that will have a relationship with the Perlin Noise if we're using that. Right, what do I want to do? When we spawned the snakes in our spawner, they all kind of went off in the same direction. So what we could do to make them have like a random direction to begin with, or to choose a direction according to randomness if we want to use randomness, or Perlin Noise if we want to use a Perlin Noise, remember, we could, when we start, if we're ready, we could say check direction first and then grow the tail, or grow the tail and then check the direction. Because in the check direction, we will go and find a new direction according to, in case of Mach 3 snake, according to some Perlin Noise. Again, they will all follow the same path. So I want to, let's just write, including this script, a boolean where we can turn off and on Perlin Noise for the path of the snake. So we want a public bool Perlin path, or I like that, Perlin path equals, we'll go false to begin with for the default. So should snake follow a Perlin Noise path? Otherwise, path is random. There we go. So now all we need to do, go down to check direction. I think I just commented out the random code, so I should be all right. So we just need to say, let's say if not Perlin path, do this. Okay, so we want our old random line. Then we want to check it against the dice face algorithm thing. See video 2 if you want to work out. I think it was video 2 that I came up with that, maybe video 3. In there. Let's get the indentation right here, sorry. Right-ish. Okay, so we're picking a new direction, making sure it's not going back through the body of the snake. Keep picking. Okay. Use Perlin Noise to decide new direction. So we could have an else here. Else use Perlin Noise to decide the new direction. And that's the end of that else. Right. I think that's fine. So let's now start our Snake 3 prefabs. Remember, the prefab is the thing that's going to be generated by the spawner, spawned by the spawner. We want to make sure that Perlin path is false. Okay, so they should all now be nice and random. So I'll just save the scene, save the project. Have I saved the code? Yes. Okay, so now finish the video. It's been about 25 minutes, I think. Oh yeah, I just remembered. If I shrink and make segments, then all of the scripts for the Mach 3 snakes will be used. Oh, I just realised I haven't put the Snake 3. I haven't put the Snake 3 prefab into our into our spawner. These are all Snake 2s. And so they all follow the same path because their initial direction is 1. So we'll leave those be. We'll leave Snake 2, no more changes to the snake brain, that original snake brain, where all the movement is kind of correct, but you can't shrink this kind of snake. You can shrink the Mach 3. So find the egg, we'll put in the Snake 3 prefab in there, and now play. So when we generate these snakes, we should get like a spray of snakes going in all kind of directions straight away. Yes, there we go. Oh, that's wonderful. And how many we've got? We've got 99 snakes. And there they go. Brilliant. So if I think I can now shrink, if I right click, I'm shrinking all of those snakes. Oh, that's pretty cool. Can I shrink them all to 1 block? Yes. No. That's interesting. Some of them have got 2. Ah, I know why that is. Because if that snake happens, if I happen to click when the last segment is the brain segment, then it won't let me delete the snake. So I have to keep clicking until probabilistically I get all of the snakes. There we go. We've kind of created star snakes and things. Right, next thing. I think in the next video, and I might have this prepared already, or I might code it in while I'm recording, we want to maybe put like apples in front of us, and then the snake go and find that precise location. Oh, also we want to make tiny little cute snakes as well. That would be really nice. Okay, thanks for watching. Leave any comments for any suggestions and etc. Okay, goodbye.